A good way to start an astronomy course is to describe our address. Well, of course, we live on the Earth, a planet orbiting the Sun that is a large glowing ball. Well, that's a large glowing ball. That is our Sun. And what is it made of? It's made of all kinds of gases. It's all right. We will talk about this. We have a whole chapter on this. Now, Earth is a planet that orbits the Sun. Now, these are two planets, Mars and Neptune. Planets may be rocky, icy, or gaseous. Rocky like Mars, or gaseous like Neptune. And planets have their moons. Not all planets, some have, some don't. This is Ganymede, the moon that orbits Jupiter. Besides planets, there are other objects in the solar system. What are they? There are rocky asteroids, there are comets, and all these put together is what we call the solar system. So a star with all the materials that orbit and orbited, and the Sun along with its planets, asteroids, comets, and other materials that orbited form the star system. And we have our solar system. And there are billions and billions of such star systems in the universe. So when we start describing our address, we first identify our home is in the solar system. Well, a star like our Sun was born in an interstellar space. Now here we have a lot of interstellar space. And what do you call it? It's called the nebula, which is a cloud of gas and dust. Stars are born from the gas and dust materials of the nebula, and after billions of years of their lifetime, they die, and the star stuff gets added back to the nebula, where the cycle of birth and death will continue. So a nebula is a place where stars are born, stars die, stars distribute the materials, and those materials are used again to form new stars. Well, our Sun is part of a great island of stars, in fact billions of stars. And that island of stars, which our Sun is a part, is called the galaxy. Our galaxy is the Milky Way. So this is the Milky Way galaxy. And what does the Milky Way contain? Milky Way contains billions of stars like our Sun, some much bigger and some smaller. Milky Way belongs to a local group of galaxies, and there are billions of such galaxies in the universe. So our address is pretty complicated. Now this gives you an idea of how vast the universe is and how difficult it is to know what happens at different parts of it. Now, how do you know about things that are happening in other parts of the universe? What is the agency that carries information to us? Well, the agency that carries information to us is light. And of course, light takes time to travel from one place to another. Now, what is the speed of light? Light travels at this speed, 3 times 10 to the power of 8 meters per second. That is about 300,000 kilometers in 1 second. Considering the fact that the distance around the Earth is 400,000 kilometers, that is, if you start at one point, go around the Earth and come back, it's 400,000 kilometers. A beam of light will circle the Earth 7.5 times a second. You see how fast light travels. And we can get information from other parts of the universe at that speed. How much is the speed of light? It's 300,000 kilometers per second. 3 times 10 to the power of 8 meters per second. All right, let me ask you. If light travels 300,000 kilometers in 1 second, how long does it travel in 1 year? Well, this is the distance it will travel in 1 second, 3 times 10 to the 8. So if you multiply that with the number of seconds in a year, that will give you the distance traveled by light in 1 year. Now, how do you do that? The distance traveled in 1 second is 3 times 10 to the 8. Multiply that by 60 times 60 times 24 times 365. That's the number of seconds in a year. That gives you 9.46 times 10 to the power of 15 meter, which is the same as 9.46 times 10 to the power of 12 kilometer. Now, this is actually 9.46 trillion kilometer. That is the distance light will travel in 1 year. Well, this distance that light travels in 1 year is called a light year. A light year. So what is a light year? Light year is the distance that light travels in 1 year. And how much is that distance? It is 9.46 trillion kilometers. So, what's our address? We live in the Milky Way, third planet from the Earth, at a distance of 150 million kilometers in the Milky Way. That is 150 million kilometers from the Sun. Right? Now, this is the average distance of the Earth from the Sun, and this distance is called an astronomical unit. Astronomical unit, abbreviated AU. So what is an astronomical unit? Astronomical unit is the average distance of the Earth from the Sun, and it is 150 million kilometers. All right, can you do this for me? If light travels, now what is the speed of light we said earlier? The speed of light is 300,000 kilometers per second. Now, how long will light take to travel from the Sun to the Earth? A distance of 150 million kilometers. Well, to find the time, we divide the distance by the speed. The distance of the Earth from the Sun is 150 million kilometers, and light travels at a speed of 300,000 kilometers per second. So dividing 150 million kilometers by 300,000 kilometers per second, you get 500 seconds. That's how long light will take to travel from the Sun to the Earth. 500 seconds is about a little more than 8 seconds. What that means is, what you see on the surface of the Sun now actually happened about 8 minutes ago. You see, the information that you get is not instantaneous. What you're seeing What you're knowing now is something that existed in the past, right? So when you look at the sun, what you're seeing at the sun now happened 8 minutes ago. And look at our galaxy Milky Way. Our Earth is right here. Okay. Now, who is our nearest neighbor? Our solar system and the sun, our nearest neighbor, the nearest star, is Alpha Centauri, and that is 4.3 light years from the Earth. What does that mean? When you look at the Alpha Centauri, what you're seeing actually happened 4.3 years ago, because in order to see it, we need to get the light from it reaching us, and it takes 4.3 years to reach us. So we say the distance of the Earth from the Alpha Centauri is 4.3 light years. All right. The largest galaxy in our group is called the Andromeda spiral. Now, we will talk about a mythical story on it in our next lesson. It is a large spiral like the Milky Way. It's about 2.3 million light years from the Earth. Look at that. Any information from this galaxy will take 2.3 million years to reach us, which means when we look at the galaxy of Andromeda, we are actually looking at what happened 2.3 million years ago. And it contains about 400 billion stars. Now, M33 is another spiral galaxy in our group. You can see that as a spiral galaxy. It is close to Andromeda, and astronomers think it could be orbiting Andromeda. Another closest neighboring galaxy is the Magellanic Cloud. Here it is. And it contains about 10 billion stars. Now, how do we take a look at what is happening outside? The means by which we can now take a look at peer outside is the Hubble Telescope. It is stationed outside the Earth's atmosphere so that we can actually view the night sky without the interference of our Earth's atmosphere. So a Hubble Telescope gives us a better view of what is out there without atmospheric interference. Point this telescope to an empty space and imagine what you see. Now, this looks like an empty space, but point the telescope to that empty space and this is what you will see. So after all, when we see empty space, that is not empty space. Look at what is there. Thousands of distant galaxies, remnants of the Big Bang receding into space, all that are there. Now, Hubble's studies have confirmed the theory that the galaxies are actually moving away from each other. The space between each galaxy is actually increasing. Everything is moving away from each other. That means the universe is expanding. Now, look at a raisin cake. If you keep this in the oven, after about an hour, this is how it will look. Each raisin has now moved away from each other. Now, this is analogous to the expansion of the universe. The galaxies move away from each other. Everything moves away from each other. The universe is expanding. Now, the expansion of the universe can also be used to estimate the age of the universe. How old are we? How old is the universe? The rate at which the galaxies are moving away from each other suggests that, well, we are going to leave those calculations to the astronomers, all right? But we use the way in which the galaxies are moving away from each other to get information that can be used to calculate how old the universe could be. And the figure that the astronomers come about is 14 billion years. So the universe is assumed to be 14 billion years ago. 14 billion years ago, the universe started from a point called the Big Bang, and all our galaxies and everything that we see originated from that Big Bang. All right. So stars are born in interstellar clouds, produce energy and new element through nuclear fusion, and releases these new elements in the interstellar space when they die. Now we will discuss this in detail when we study our sun in more detail. And also, everything in the universe actually is made of star stuff. So when I talk to you about the nebula, what does the nebula contain? The nebula contains dust and gas, and that is where stars take birth. Stars are made of those materials, not the star stuff. We are all made of the star stuff. Materials that are manufactured from the simple elements born in the Big Bang, and the simplest element is hydrogen. Now, as I said before, light is the principal source of our information. And what is the speed of light? Light travels 300,000 kilometers a second. It takes 8 seconds to reach the Earth from the Sun that we talked about. It takes 2.5 million years to reach us from Andromeda Galaxy. We talked about that too. That means what we see of Andromeda Galaxy now is how it existed 2.5 million years ago. We know something is out there because light from that something reaches our eye. Because the universe is about 14 billion years old, we cannot observe light coming from anything more than 14 billion years away, isn't it? Well, if anything that is coming to us beyond 14 billion light years away, can anything be there beyond 14 billion light years? Well, if there is something, we will not know about it because light from that something cannot reach us. The light from that something has been traveling for 14 billion years. It hasn't reached us yet. Now, assuming we see a supernova 3 million light years away, what we are watching now occurred 3 million years ago. So, tell me, what part of the universe is visible to us? Well, this is a question we will try to answer as we go on with this course. So, now the question is, how big is the universe? How big is the universe? Well, how many stars are there in the universe? The Milky Way is one of 100 billion galaxies. That is, there are 10 to the power of 11 galaxies in the known universe. And each galaxy contains 10 to the power of 11 stars. So how many stars are there total? Now, when we say total, we are making an estimate of the universe that we can comprehend. There may be something else beyond it. Well, as I said, if there is something beyond 14 billion light years, we don't know it. And the likelihood is that there are a lot of things beyond there that we don't know. So how many stars are there in the universe that we can comprehend? About 10 to the power of 22. How big a number is that? Well, you can figure it out. Now, it may be easier to count the number of grains of sand in all our beaches than counting the number of stars in the universe. Now tell me how easy that's going to be to count all the grains of sand in all the beaches on Earth. If you can do that, then maybe you can attempt to count the number of stars in the universe. Now, both seems to be impossible task. Now, if there are 10 to the 22 stars, and each star has planets, then how many planets are likely to be there? Make an estimate of the number of possible planets in the known universe. Milky Way has probably 40 billion Earth-like planets. And there are billions of such galaxies. So, how many billion planets are likely to be there? And how many planets like the Earth are going to be there? And how many planets like the Earth that sustain life? Is there life outside our Earth? All these are intriguing questions that we need to answer, or can we get an answer? Well, we will talk about it. Okay. Now, we know that our Earth is moving around the Sun, completing one revolution in 1 year. In addition to the revolution of the Earth around the Sun, it also has a rotational motion. Now the Earth rotates. Now remember, something can rotate about an axis. Now this is the axis of rotation. Now the Earth rotates about a vertical axis. But as we said earlier, this rotational axis is not exactly vertical. It is inclined at 23.5 degrees with the vertical. And we talked about this earlier. The axis of rotation is 23.5 degrees tilted to the vertical. Now, what is the direction of rotation? You can see the rotation is counterclockwise. What is the direction of revolution of the Earth? Now, do you notice the two words that I have been using? Rotation and revolution. Rotation is the rotation of the Earth about the axis. Revolution is the motion of the Earth around the Sun. Now, the rotation is counterclockwise. And the revolution also is counterclockwise. Now, that means every point on the Earth is actually in perpetual motion. Well, when the Earth is rotating about an axis, a point at the axis there is really not moving. But a point here, a man here, is actually going round in circles. How fast? Is 1,275 kilometers an hour. So the man on the surface of the earth, somewhere here, is actually moving very fast. If you are on the equator, you're moving even faster, 1,650 kilometers per hour. You understand why? Because when the earth completes one rotation, a man standing on the equator goes around a larger circle than the one here. But both these circles have to be completed in the same time. That means this man has to go much faster, right? So, although we don't feel it, we are in perpetual motion due to the rotation of the earth, and we are in perpetual motion because of the revolution of the earth. Well, and the earth revolves going round the sun in 365 days. What is the average speed? The average speed of revolution is 108,000 kilometers per hour. 108,000 kilometers an hour. So look at the kind of motion you have. You're moving because of the rotation of the earth. You are moving because of the revolution of the earth. So if you are here, you are moving 1,275 kilometers per hour because of the rotation, and 108,000 kilometers an hour because of the revolution of the earth. Is that all? Well, our sun itself, now this is again a depiction of the revolution and rotation. This is a revolution. And you can see the axis of rotation is 23.5 degrees with the vertical. Right. Now, we are moving because of the rotation of the earth. We are moving because of the revolution of the earth. And what is the average speed of revolution? 108,000 kilometers per hour. And the path taken by the earth, you see the path taken by the earth around the sun is called the ecliptic, and the plane containing that is called the ecliptic plane. Now we will come across this ecliptic again in the next lesson, but in the next lesson we are going to say it is the apparent path taken by the sun around the earth. Well, actually the ecliptic is the path of the earth around the sun. But when we are on the surface of the earth, we feel as though the sun is going around us. So this is also the apparent path of the sun around the earth, and we call it the ecliptic. Okay. Now, not only the earth is moving, but the sun itself is moving. Well, our sun moves randomly. Our sun actually moves around the center of the galaxy. Our sun moves randomly relative to the other stars. I mean, these are all billions of stars there, at an average speed of 70,000 kilometers per hour. So our sun is moving around the center of the galaxy at a speed of about 70,000 kilometers per hour. And it completes one orbit every 230 million years. So it takes the sun to complete one of these circles. The time taken is 230 million years. You can see all these combined, what a complicated address we have. What a complicated place we live in. We think we are peaceful, quietly sitting and sleeping. Are we? Well, At this juncture, before advancing any further, it is worth asking the question, how do our lifetime compare to the age of the universe? Well, we think we know so much about the universe. Can you think about that little question? How does our lifetime compare to the life of the universe? The universe has been there for about 14 billion years. What is the average age of a human being? Well, the life expectancy in the United States now is about 78 years. How does that 78 years compare to 14 billion years? Well, we painted a spectacular picture of the universe, gave a spectacular picture of our address, where we are in the universe. Yet, everything is not rosy. Why? Because our Earth revolves around our expiring sun. Our sun will die in another 5 billion years. So, the sun is scheduled to burn out in just 5 billion years. At about that time, our Milky Way will collide with our neighboring Andromeda. Can you imagine what that will bring about? Oh, so what kind of a picture are we going to paint? What kind of a universe are we going to leave for our generations, later generations? Well, think about the lifespan compared to the life of the universe. Our sun is going to be there for another 5 billion years. Will our civilization last another 5,000 years? Well, think about it. Well, in the meantime, before it all ends, try to answer some of these small questions. Why can't we see a galaxy 15 billion light years away? Choose an answer to see if you understand what we discussed so far. All right? Let's look at another question. On our 1 to 10 billion scale, it's just a few minutes walk to Pluto. If you reduce the universe scale 1 to 10 billion, that means Pluto will be a walking distance. At that scale, how far would you have to walk to reach the Alpha Centauri? Will it be a mile, 10 miles, 100 miles, or distance across the US, 2,500 miles? Think about it. Make a posting on the discussion board. That is the way we can answer these questions. All right? Share your ideas.